This problem is referring to the graph edge coloring. So suppose we have a graph, we have a connected graph, and we want to paint the edges in a way that no two edges that have some mutual nodes have the same color. So look at here, look at the node 9. There are 4 edges connected to this node. None of these edges should have the same color. So we want to find out what is the minimum number of required colors to paint this graph. Okay, so let's write down the codes. So here you can see that for every node we should have some limits. So let's, for every I and C we have to write down this constraint. So it is saying that summation of xi j c, and the summation is over j, whatever is connected to I, should be less than 1. It means that the summation of all the edges that are connected to one specific node should be less than 1, and this is valid for every I and C. So no two edges have the same color if they are connected to one node. Okay, and the other one is like the previous one, like the node coloring one. So y is bigger than c, x, I, c, I, j, and c. And also we should say that every edge should take only one color. This is the last equation. Okay, so if I run this simulation, this is what you get. So you can see here that how the graph is colored and the number of required colors are determined. Okay, so let's have a look at the Python code for this problem. Here you can see that first of all we need to import the required packages like matplotlib, networks. Here it's not needed to re-import that. I can remove this one, so because we already have it here. So I create a random regular graph with the degree of 4 for each node, and there are 30 nodes, and I plot it, and then I import the required kind of packages, construct a model. So that model is an abstract model, and it's the number of nodes. As you can see, it is initialized with the number of nodes and the number of edges. I and j are the set of nodes. L is the connection matrix. Color is the color. And also x and y are 2 variables. X is defined over I, j, and color. So it means that the color of no edge which is connected between node I and node j, and y is the objective function. Okay, so in order to solve that, we should create a constraint, saying the first constraint actually. So if I show you that again, so here I'm writing on this one. Okay, so in order to write it down, I write this expression. So initially the expression is equal to 0. Okay, and for every j in the model j, if j is connected to I, so x, I, j, and c is added to the xi, or if lji is 1, then xji will be added to the model, and that expression should be less than equal to 1. Okay, and that constraint is defined over model I and color. And this guy, instead of writing down y bigger than c x I j c, I wrote it this way. I did the summation over all color and I and j if they are connected to each other. And this is why the reason that I'm doing this is that if I define it y bigger than c x I j and c, this means that for every combination of I, j, and c, I have to create a constraint. Okay, and that will hugely increase the size of the model. Okay, but that kind of modeling gives you the same kind of result. And finally, every edge should have only one color. Okay, and finally the objective function is y and the model is glpk. We can specify the gap for the mixed integer programming, which I did it here, so I can run these tabs and show you the results. Okay, so first of all, we have to create a graph. Okay, and this one. Okay, so here I have to create the L part and also N. This is one way of creating the data and feeding it into the Pyomo. So I create a dictionary and fill every required parameter in the model. Okay, so I run it again. So it is run, and I here just the model is being fed with the input data. Okay, and the model is solved, and you can see the results here. So the results is telling me that it's showing that IJC and the value of it. So IJC and the value of it is that, so it means that the node between 0 and 17 is colored with the color number 3. Node between 1 and 6 is colored with number 2, and so on and so on. Okay, and you can graphically see what's happening here. Okay, so here you can see that, for example, at node 13 4 colors are used, and so on. Okay, and that's it for this example. Thank you very much.